Okay, yeah. All right, where were we? Where were we? Where were we? We were talking about links. Add, remove, removing from the end. And then we created like this node class. But remember, the node class, it's just a node. And then when we were playing around with the implementation, all we did was make a series of, this isn't a main. There's no like link structure class. It's just a node that were chained together. And we were playing with it in a main method here, okay? That's what we were doing. And then this is where we like ended. And I want to be very clear, saying head equals some node versus head.setNext to some node. Two very different things. Head equals some node says the reference variable head reference the same thing said node references. When I say head.setNext, I'm saying, hey, head, set your next field to some node. Just be careful. This was something the reason I bring this up is I remember I was like messed up with this. And then there was like this click moment of like, oh yeah, okay. So just be aware of that one. And then a variation. There are as many variations as we want. Like we were talking about singly linked structures where each node had a reference to its successor. But then that had the problem of like, well, if I'm at some node and I want to go to the one before it, how do I do that? You can't. We can in that roundabout way of starting over and going until we find what we're looking for. But there was no direct way to do that. We could have a doubly linked structure though. Why not? You can have a node with two fields. There's nothing stopping us. A node with two fields, one is the data, one is the next, and another is the previous. So you can traverse in both directions. It's entirely fine. We're not going to implement this one. You can if you want. Nothing's stopping you. But we're not going to implement this one here specifically because we don't need, it's like what we have with a singly linked structure is sufficient. But of course, like implementing a node with an additional field, it isn't that much more complex. It really isn't. You know, your adds and removes require a little bit more bookkeeping, right? If I deleted this node, I have to update this one's next, but also this one's predecessor. So there's a little bit more bookkeeping involved. But at your stage, this shouldn't be something that's overwhelming. So the reason we're not doing a doubly linked is not because you're not capable of doing it. No, you absolutely should be completely capable of doing this. It's because we really don't need to for our needs. We're just going to stick with singly linked structures. Okay? Okay, cool. All right. Any last questions about these linked structures and nodes? We're going to see a lot more of them, but you know, we've introduced it. Any other questions or anything? Okay. All right. So I just made this big to-do about how like a linked structure is not in and of itself like a collection, right? It's more like a container. And an array is a container. A container in the sense that like, okay, it can store information for us, right? And then we can manage that, like we have a class that manipulates that information in a well-defined way that makes a stack or a queue or a whatever. So we were using an array, and we just spent all this time talking about a link structure. Well, yeah, we can treat this link structure as a container and then use that container to make a stack. So let's make a linked stack. Before we had an array stack, and the name of the class, the concrete class, array stack told us we have a stack made with an array, right? If we have a linked stack, it's a stack made with a link structure. The name of the interface is stack. But the actual concrete implementation, the name of that class, tells us a little bit about the specifics of that one. On assignment 1, did you use a map? You better have, right? But when you made the map, what was it called? Was it called a map? It was called a hash map, right? Well, a hash map is a map. but its implementation is based on this like hashing idea, which is the same idea as of the hash code, by the way, but no, we're not going to worry about that. So that's the convention in Java. In other similar languages, they have a slightly different convention. Like I think in C#, every interface is called like I stack, like it starts with I. But whatever, it's neither here nor there. Yeah.
So there's an interface in the Java code
for a map. For a map. Yeah. So when you made it, now no one would have lost marks for this, but when you make your reference variable, what was its type? Did you make a hash map reference variable? Because if you did, that's entirely fine. But a better way would have been able to make like a map reference variable that references a hash map. But it doesn't matter. Let's confirm I'm correct on that. Yeah, map. And now it's there, right? So we've got a map of, let's say, integers and strings, right? Map equals a new. Now I can't make a new map because a map is an interface. And you can, it even tells you here with a little I. It's an interface, it's green, right? So I can't do that, but like what kind of map? Well, I want a hash map, right? Yeah.
There could be different type of hash.
There could be a different implementation of a map. Now, I'm pretty sure there really is only like a hash map. There's a tree map. Cool. Well, that's a different thing. That's going to be, I know, that's going to be somewhere like in between. It's a whole thing. Yeah, so here, let's make an abstract map. And if I go to here to abstract map, you'll see like some of these things are, it's an abstract class. So you'll see like, look, some of these things are implemented. So first of all, notice that it implements a map. So it gets everything for a map, but it's an abstract class, meaning not everything from a map necessarily needs to be implemented, but there's going to be some concrete class things that are implemented. So it's kind of like in between an interface and a concrete one.
So then you'd make something else that extends the
yes,
abstract map?
Nailed it. Yep. Yeah. And you use the right word, extends. Yeah.
K and V, are these like objects, like T?
Yep, K and V, key value. It's generic, but a map has two generic types in it, right? What is the type of the key and what is the type of the value, right? Right? That, if you remember dictionaries, if you're like, what is it? Think back to dictionaries from Python. It's a key value pair, but what is the type of the key? What is the type of the value? We could have used T for one of them, but like everything that's a T needs to be a T. The key and the value types don't need to match. But everything that's a type of the key, well, they all have to be the same type. Why K and V? Key value. The label here doesn't really matter. There are some conventions we follow, but K, V, key value. Yeah. Cool. All right. Now, think back to the stack interface. What do we need to have a stack? Push, pop, peek, is empty, and size. The interface only defines what a stack is. The array stack was an implementation of a stack. It's where we defined the how. We could define the how an entirely different way as long as it does the what correctly. All that matters is I have an implementation that does push, peek, pop, is empty, size, and it all works how it's supposed to. You've got a stack. Now, if you make a stack where you push on one end and pop on the other, well, you could say you've implemented a stack, but you've got a really terrible stack because it's not a stack. But if you implement everything properly, and it is in fact a stack, as far as Java is concerned, a stack is a stack. So we have an array stack. We're going to make a linked stack. So here's the idea we want to follow. We have a head. I'm going to refer to the head as top. It's going to be the thing at the beginning of the stack. Now, we have an implementation decision to make. We have a design decision to make. Do I want the top of the stack to be at the end of the link structure or at the beginning of the link structure? This is a consideration. Is there pros and cons to one or the other? Well, as it turns out, with a link structure, there really is no pro to having the top be at this end. because every time I would want to get down here, I'd have to go like all the way down to find it. I could have another reference variable referencing the last thing, but then when I update, there's going to be a lot more bookkeeping. And just in general, having the top of the stack be the end of the link structure is kind of a pain in the butt. But remember, with the array implementation, having the top be the end was actually kind of nice. Where here, no. We're going to have the top be the thing here. So we have a reference variable called top, which is a reference to the thing on the top of the stack. And we're going to have another one called size. Unlike the array stack, size is not doing double duty. Size, well, first of all, it was called like top, right, in the array stack, where top was the next available spot and also the number of things in the stack. Here, well, you don't index a link structure, so there's nothing to index. Like, these things are entirely separate from the array stack's implementation. We are implementing a stack, but the fields here for the linked stack are going to be for the linked stack. They don't care at all about the array stack. They are entirely separate. They want nothing to do with one another. So this is the idea of if I had a stack S where I had 4 things on this stack. Cool? Cool. Okay, the top of the stack will be managed by a field called top that references the head of a link structure. All pushes and popping will happen at this end. If I push something, you might remember, oh, that's just adding to the front of a link structure, which was pretty easy, right? New node equals the top, top equals the new node. There, done. How about popping? Top equals tops next. Perfect, done, easy peasy. Pushing and popping, the idea of adding and removing to the front of a link structure was pretty straightforward. Turns out a link structure has a pretty straightforward implementation, or a stack has a, you know what I mean. Yeah?
Well, that top still wouldn't return.
We'd have to be like, okay, top, what's your data? Top equals top, next, return the data. So yeah, we would need to keep track of that too, yeah. But in terms of like adding, removing from the front of a link structure, those are the easy things to do with the link structure. So we're in great shape. So if I wanted to push something, well, this is what my linked stack would look like. Push this baby blue. That's what else would you call? What color is that?
I'd say baby blue.
Baby blue. Okay, nice. Baby blue. Push it. Okay, so now it should be in front of this thing. So what do I say? I say, okay, the new node reference this data, and your next is top, which was this, right? And then top, you equal the new thing. Boom, there, we're all set. That's it. And then pop is, remove it, pop again, remove it. Cool. Cool? We're just removing from the front of a linked structure. Happy, sad, angry? Any other feelings? What else? Questions, thoughts, concerns, comments, anything? Yeah? Yeah?
The push statement would still have like the thing that we talked about last week where it was like, it references this one.
Yes, we'd have to be careful. And we would also need to like update the size field as well. Like right now, we're only talking about general ideas. We haven't looked at the implementation yet. Speaking of, let's start talking about the implementation. 1, 2, 3, 4, 5, 6. If I was paying attention, I should have had an activity today. Anyways, let's look at the implementation. There's no activity right now. It's fine. Don't worry. We don't have enough time. It would be nasty. Why is everyone grinning, smirking like, what? Because I counted how many people were here first? You bet I did.
That's why it's funny.
Yeah.
Yeah, and it's also
You bet if there's a day where there's like 10 people here, oh, I'm going to have like 4. Yeah?
You can do that on Friday.
Oh, no.
Why would I not?
yeah, do that on Friday. It's hilarious.
Because he wants it. We're going to do it. It's his fault. Don't look at me. Do it on Valentine's Day? Is that Friday?
Yeah.
Oh, perfect. Yeah. So why would I not do it Friday? It's a school day. What are we doing here? Reading week starts on the next week. There's a whole weekend and a holiday in between. Come on. All right. Let's start looking at a stack implementation. Public class linked stack, it's generic, implements the stack interface. So if I were to start typing this into IntelliJ, IntelliJ would yell at me, being like, where's all the methods? I know, we're implementing it. Shut up. So we're working on it. We have two fields. We have top and size. Right? Top is a reference to a node of type T. That's a reference to, well, one of those things. Remember, there is no like linked structure class. It's just going to be nodes that are strung together. And then int size. Why is it not integer? It doesn't need to be. It's just an int. There's no need for making it the object version. You'll notice we don't have a default capacity. Why don't we have a default capacity? Because that doesn't even, why would we need one? There's no need for that. You'll also notice we don't have that not found sentinel. Now, if you remember correctly, that not found sentinel value, that constant that we set for the array stack, that was only used in the internal workings of the class, right? So, because we had that find method that would return -1 if something wasn't found. Well, from what I can tell here, it seems like maybe the implementation that we're going to use, we may not actually need that. But I honestly can't remember. Maybe I add it later. I don't know. We'll find out. But it seems like maybe we don't need that. And then a linked stack. When I make a new stack, it's empty. You remember the array stack. We had two different constructors, and then we used constructor chaining. One, you specified the initial capacity of the underlying array. There is none here, though. The other, you didn't specify the initial capacity, but then it used that default capacity, which again, there is no array to set the capacity of. So a new empty stack, its top is null. There's nothing in it. So what should be on top? Nothing. And what's its size? 0. If you looked hard enough, you could probably find some implementations of a stack out there where they have this like dummy node that means like empty, that effectively is the same idea as null. I'm sure you could find something like that. We're not going to do that. That's extra work for no value. Any last questions before we wrap up? Yeah.
Yeah, I remember that we were talking about like whenever you create like a list, you create a reference to a spot in like the physical space where it's sort of like all in order. But in this case, it has a whole bunch of different references. So is it, for a new one, does it create a reference like just in a random location?
Yeah, it's going to be all over the place. Now, technically, with any list, it'd be all over the place. Technically, with an array, it would, but conventionally speaking, an array would be a contiguous chunk of RAM. But in reality, in Java, there's no such guarantee, but that's how we like to think about it. When you have a series of linked nodes, there's going to be a node over there, a node over there, a node over there, a node over there, and they're all going to be referencing each other like a giant web. But as long as you follow the next, you'll always find it in order, all over RAM.
Which is great.
Which is,
What is its size?
yeah, it's fantastic.